In this lesson, we will learn all the ways to prove triangles congruent. In order for any polygon to be congruent, every corresponding angle and side must be congruent. In this diagram, angle A is congruent to angle F, angle B is congruent to angle E, and angle C is congruent to angle D. We also know that side AB is congruent to FE, side BC is congruent to ED, and side AC is congruent to FD. Because we know every corresponding angle and side are congruent to each other, we know that triangle ABC is congruent to triangle FED. Because of the special relationship between the angles and sides of triangles, there are 5 shortcuts to proving triangles congruent. The side-side-side congruence postulate states if 3 sides of one triangle are congruent to 3 sides of another triangle, then the 2 triangles are congruent. In the diagram below, it was clear that side KL and side LN are congruent, as well as side KM and NM are also congruent. Side LM is shared between the 2 triangles, so that is congruent because of the reflexive property. Since we meet all the criteria of the side-side-side congruence postulate, we can make a congruence statement. Triangle KLM is congruent to triangle NLM. The side-angle-side congruence postulate states if 2 sides in the included angle of a triangle are congruent to 2 sides in the included angle of another triangle, then the 2 triangles are congruent. In the triangle below, segment BC is congruent to segment AD, and that is given information in the diagram with the single tick mark in each of those. We also know that AC is a segment that is in both triangles, and it is congruent to itself. And the reasoning for that is the reflexive property. You may also notice that BC and AD are parallel to each other. That's denoted by the arrows on their line segments. These parallel lines form a transversal with side AC, making angle BCA congruent to angle DAC because they are alternate interior angles. Since we know that 2 pairs of sides in the included angle between those sides are all congruent to each other, triangle ABC and triangle CDA are congruent using the side-angle-side congruence postulate. The angle-side-angle congruence postulate states if 2 angles in the included side of a triangle are congruent to 2 angles in the included side of another triangle, then the 2 triangles are congruent. In the diagram below, the markings indicate that angle A and angle D are congruent to each other, that angle C and angle F are congruent to each other, and that segment AC and segment DF are congruent to each other. Since segment AC is found between angle A and angle C, and segment DF is found between angle D and angle F, we can prove these 2 triangles are congruent to each other using the angle-side-angle congruence postulate. One possible congruence statement could be triangle ABC is congruent to triangle DEF. The angle-angle-side congruence theorem states that if 2 angles in the non-included side of one triangle are congruent to the corresponding parts of another triangle, then the triangles are congruent. In this diagram, the markings indicate that angle A is congruent to angle H. Also, Angle B and angle J are both right angles, and all right angles are congruent to each other, so angle B and angle J are also congruent to each other. Also, segment CB and segment JK are congruent to each other. Because the congruent sides we know are not located directly between the angles that we know, we cannot use the angle-side-angle congruence theorem, but instead we can use the angle-angle-side congruence theorem, since CB and KJ are not between the two known congruent angles. We can now write a congruence statement. One possible congruence statement is triangle ABC is congruent to triangle HJK. Our final shortcut to proving triangles congruent is the hypotenuse-leg congruence theorem, which states if two right triangles have congruent hypotenuses and corresponding congruent legs, the two triangles are congruent. In this diagram, we notice that triangle ABC and triangle DCB are right triangles. The right angle in ABC is angle B, and the right angle in DCB is angle C. We also notice that the hypotenuses AC and BD are also congruent to each other. Segment BC appears in both of the triangles and is congruent to itself using the reflexive property. We now have enough information to prove these two triangles congruent to each other using the hypotenuse-leg congruence theorem. One possible congruence statement we could use is triangle ABC is congruent to triangle DCB. The use of these 5 shortcuts to proving triangles congruent, side, 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 angle, side, hypotenuse, leg, angle, side, angle, and angle, angle, side, should greatly simplify proving triangles congruent to each other. Now it is time to try to prove some triangles congruent yourself.